Okay guys, it's a very quick video on standard form. It's going to be pretty lazily made, I'm afraid. Just need to get the information out there as quick as we can, because the exams are coming pretty quickly. It's just a useful way of writing big and small numbers, as in, like, if you write very big numbers and very small numbers, you have loads of zeros and loads of numbers, and it's cumbersome. There's numbers everywhere. So what we do is we write them in standard form, and then they take up a lot less space, they don't get tiresome to write out over and over again, etc. If you look at the two examples, we've got one example of a very big number, 120 million, one example of a very small number, God knows what that is, but it's very small. You can see it. How does it work? Look at the first three digits of the very big number, 120, so 1.20. Count how many digits after the first one, that tells you the power, 10 to the 8. Pretty simple. So 8 digits after the 1, so 10 to the 8, the first three digits are 120. That's how you work it out. As for the second one, first three digits that aren't 0, 175. So 1.75, and 6 zeros before the first digit comes in, so that's where that comes from. That's why it's minus 6. Well, obviously the reason why it's minus is because we're talking about a very small number this time, so I hope that makes sense so far. Here comes my hand again. I told you this one was going to be very kind of exciting. Just a couple of things before we go on to this topic, multiplying standard form numbers. Well, first of all, if you had bigger numbers, as in like, so they weren't all zeros, you'd still only look at the first three. So that means standard forms can sometimes be an approximation. You don't get all of the accuracy you'd get from having the number written out completely if not all the numbers are zero. It's important for you to know that. But beyond that, not much else to say really. Multiplying standard form numbers, easy enough. Multiply numbers in front, 3 times 2. Add the powers, 7 plus 6 is 13. 6 times 10 to the 13. Sometimes, though, you do get a bit of a problem, and the problem is that you may get something like 5 times 3 is 50. Now, you might have noticed with all these standard form numbers, the numbers themselves are between 1 and 9.99. And to be fair, if I was doing this completely properly, I'd probably write that as 6.00 times 10 to the 3 above, right? 15 is obviously bigger than 9.99, so what do? We shrink it down to size, make it 1.5, effectively dividing by 10, and add a power to the pack of powers that I have there. So it's 10 to the 10 becomes 10 to the 11. So that's my way of getting around the problem that sometimes when you multiply standard form numbers, you get a number that's not automatically in standard form. That's what you do for that. Dividing standard form, much of the muchness. Instead of timesing at the beginning, you divide, and instead of adding at the end, you subtract. So 3 divided by 2 is 1.5. 10 to the 8 divided by 10, so 10 to the 8 divided by 10 to the 4 is 10 to the 4. So we subtracted 8 minus 4 is 4. The other one can also have a problem as well. 4 divided by 8 is 0.5. Again, that's not between 1 and 9.99. So that's problematic. So what do? We turn it, basically we increase it. We let it become up, so it becomes 5. What happens after that? We take one of the powers off to compensate for the fact it's almost like we borrowed a 10, we times it to the 0.5 to turn it into 5, and now we've only got 9 lots of 10 left. Alright? I hope that makes sense. It should be reasonably... Well, to be honest, that was really fast and a bit rushed. But given the timescale, not too many apologies on that. I will teach you in class. Sorry. Bye.